Welcome to this series of videos on the gnuplot plotting program. Now gnuplot is a wonderful program capable of many things, but in this series of videos I will focus mainly on its ability to plot two-dimensional graphs. At the very outset, let me warn you about one thing. gnuplot is a command line driven program. What this means is that in order to use it, you will have to type commands at a command line rather than click buttons on a point and click interface. This might seem a bit daunting at first, especially if you're not used to command line programs. However, once you get the hang of it, you will see that it is this very command line driven nature of gnuplot that gives it its power and ease of use. Enough talk, now let's get to action. In order to run gnuplot on my Ubuntu machine, what I have to do is first start a Linux terminal. I have just picked one that has already been running for some time, and now in this terminal I will issue the command which starts gnuplot. There are no prizes for guessing what that is. It is simply gnuplot gnuplot, then I hit the enter key and gnuplot starts. Once it starts, it gives me some pieces of information like which version it is, who the copyright owners are, where to find the home page, how to find help and so on, what the terminal type is. Finally, the most important piece of information is shown at the very end. As you can see on the last line, the writing on the screen says gnuplot followed by a greater than sign. This is the gnuplot prompt. It means that gnuplot is now ready and waiting for you to give a command, which it can then execute. So we will start with a very simple task. We will plot the graph of a very simple function, one which is familiar to you from high school trigonometry, namely the sine function. Now gnuplot knows the sine function as well as many other mathematical functions that you may be aware of, including some which you may not even be aware of. And the way to refer to these functions is more or less the same as the way you refer to them in mathematics. So for example, to call the sine function, you will type sin, the name of the function, followed by the argument x in round brackets. This is very important. The argument of a function goes in round brackets and not any other kind of bracket, just round brackets. So to plot the sine function, I have to simply type plot for plot and then type sin x and hit the enter key. Once I do that, the sine graph appears on your screen. Now we will move next on to more complicated graphs. But before we do that, let us take some time off and take a look at some details of this particular curve. As you can notice, the x values on this graph go from -10 on the left to +10 on the right. This is the default behavior for gnuplot. Remember, when I wrote down the plot command, I said absolutely nothing about the range of x values to be used. So, if you are issuing the plot command to gnuplot and do not specify the x range, and you are plotting a function, gnuplot automatically assumes the x range to be from -10 to +10. This is the default behavior, which of course can be overridden by the user if he or she wants. What about the y range? In this case, you can see the graph go from -1 below to +1 above. This is again the default behavior for gnuplot, but it is not a fixed range. This is an example of autoscaling in action. What gnuplot does is that it takes a look at the minimum value that y takes in the range in which the graph is being plotted and the maximum value it takes, and uses these two values together to decide on the scale to use on the y-axis. This is auto-scaling, the default behavior, which can once again be overridden. The curve itself is drawn in blue, which happens to be the default color for the first curve that I draw on my screen. This, of course, is for my system. In your system, the color of the first curve might very well differ. But whatever the color is of the first curve, that is consistent throughout. What I mean is, if your first curve is drawn in red today, until you change the gnuplot version or override this, the default will continue to be red. Now you may have noticed that near the bottom left, there are two numbers which keep on changing when you move the cursor within the region called the canvas, where the graph is being drawn. These, of course, are the coordinates, x and y coordinates of the current location of the mouse. For example, if I place the cursor as close to the peak here that I can, the coordinates read 1.56261 and 0.995861. Of course, they should really be reading pi by 2 and 1. The difference is simply because I have not been able to locate the peak that well. On the top right corner, here you have a legend which tells you what the name of the graph that you have plotted is. In particular, in this case, it is just using the function name that you plotted by default. And the horizontal line next to it shows that the color of the line is blue. Of course, here you have only one curve in your graph, so this is not really necessary. However, as you will soon see, you can plot several curves on the same graph, and if you do, plotting them with these different legends really come in handy. There are also several other things, like you have minor ticks here, ticks on the x-axis. But one thing is missing, which is really sticking out like a sore thumb. One thing which every self-respecting graph should have is not there on our graph, which are the axes. This is again the default behavior for gnuplot. It does not plot the x or the y axis by default. In order to turn off this default behavior and turn on the behavior in which the x-axis are plotted, we will have to use a command which helps you to set the various options. In this case, the command is simply set. And we will have much occasion to use this set command for different purposes later. But for the time being, what we want to do is set the 0 axis. And this is the command that we use for it. Set 0 axis. I type this, hit enter. Now take a careful look at what is happening to the graph as I hit enter. Well, don't think there is something wrong with your eyes if you see nothing happening to the graph, because nothing really is happening to the graph. This is because any option that you set using the set command is actually applicable to future graphs, graphs you are going to draw henceforth. They don't affect graphs which have already been drawn. So in order to see my sin x graph with the x-axis and the y-axis plotted, you will have to do something else. What you need to do is to plot the graph again. So I can either type plot sin x again or use the arrow keys, the up and the down arrow keys, to bring back old commands. In fact, you can even bring back commands from previous sessions of gnuplot, not only this one. Or you could use a third way, which is just use the command replot. Replot makes gnuplot plot the same function or the same graph as last time, but with the current options. So if I hit, I type replot and hit enter, you see the graph now has the axis drawn. The x-axis and the y-axis have been drawn. Now, as I have said, the default X range is from -10 to +10. You may very well want to change that. So you could use set X range followed by the range you want in order to do this. However, that's not a very good idea for the simple reason that setting the X range in this way means that all subsequent graphs will be plotted with this same X range. It will be much more useful and flexible if I could specify the X range while supplying the graph to be plotted to the plot command. And you can actually do that. All you have to do for that is, in the plot command, right after stating plot, you have to give the X range in a square bracket. And the way you do that is, suppose you want to plot sin x again, but this time from -3 on the left to the +15 on the right, you open a square bracket, type -3, the value up to which you want to go on the left, follow it up with a colon, which is for separating out the two pieces, and then type 15, which is where you want to go up to. End the square bracket, and then hit enter. Now you can see that the graph has changed. It is now from -3 to +15. The y range, of course, stays the same because of auto scaling. Y, of course, goes from -1 to +1 even for this X range. And as you can see, the axis, in particular the y-axis, has shifted a lot to the left, simply because the plot is now no longer symmetric over X values, but from -3 on the left to +15 on the right. Now, if you wanted to use just the default value of +10 for the right hand side and -3 for the left hand side of your X range, you could have just written plot square bracket -3 colon and ended the bracket. If you do not specify the ending value of value to gnuplot, it automatically assumes the default value +10. So now the graph goes from -3 to +10. You could do the same thing for the left hand limit. If you don't specify the left edge, you are going to plot from -10, which is the default left hand value, to +15, which is what I have specified. So far, this is for the X range. Oh, by the way, you could also say this, which as you can guess makes gnuplot just use the default values of -10 and +10 for the X range. What about the Y range? To specify the Y range, let's say I want the Y range not to be the auto-scaled version, but this, -2 to +2. All I have to do is give this range from -2 to +2 using a similar syntax, square brackets to delimit the range, colon to separate the two values, but you have to give it in a second square bracket after the X range. And this is what happens. And now you have a graph which goes from -3 to +15, that's the X range, but from -2 below to +2 above, the Y range that you have specified. Of course, you could just leave the one end of the Y range unspecified like before, and then it takes the value 1 in this case, because 1 is the maximum value which the function takes. So it auto scales on the top side, but the bottom has been specified to be -2. Now suppose I want to plot this graph, say with the Y range of -2 to +2 plus 0.5. I can do that. All that is going to happen is that since the sine curve takes values which exceeds 0.5, those parts of the graph will simply be chopped off. As you can see, the parts of the sine curve here, and also here are not being drawn because they are beyond the Y range that I have specified. Now what will happen if you wanted to specify the Y range, let's say from -2 to +0.5 as here, but wanted to leave just the default value for the X range? What you cannot do is this. Because if you did that, then there is no way for gnuplot to know that you meant the y range. It always assumes the first square bracket to be the range for the x's. So it will now plot sin x, but from x equal to -2 on the left to x equal to plus 0.5 on the right. And in case you're wondering, the scaling on the y-axis is from -1 to plus 0.6, which is because the minimum value of y is -1, but the maximum value is somewhere around 0.5 in this particular range of x's, and so gnuplot just decides to plot up to 0.6 to get a nice rounded off upper limit for this auto scale. But going back to the original curve that I wanted to plot, with -2 to plus 0.5 along the y-axis, but the default value is -10 to plus 10 along the x, I could of course type out -10 colon plus 10 at the first square bracket, but there is an easier way. The easier way is simply to keep an empty square bracket at the beginning. You could put a colon inside the empty bracket, but that's not necessary. An empty bracket will do just fine. The empty bracket is essentially telling gnuplot that I am not specifying any range for x's, and the y range is going to be the one in the second square bracket. That is the range from -2 to plus 0.5. I have to give an empty square bracket for the x range, even if I don't want to specify the x range. That's simply to tell gnuplot that the -2 to plus 0.5 is actually for the y and not for the x. If you do that, you can see that you get a graph for -10 to plus 10 for this. Now let's go back to the default x and y ranges once again, but this time let's plot sine of 5x and see what happens. One glance and you can see that this graph does not really look like the sine of 5x that we expect at all. That should be a smooth curve. This one is rather jagged. Looks like somebody has plotted some points at random and just drawn lines through them. That would be almost right, except the gnuplot does not choose points at random. What it does by default is that it samples 100 points. What does that mean? It means that the x range is divided into 100 points, the left and the right hand value included. 100, by the way, is the default. So -10 to plus 10 in this case is divided into 100 points. That's 99 intervals, by the way. And what gnuplot does is that what any plotting program would do is plot these points and join successive ones with straight lines. Now, if the function whose curve you're drawing is such that it does not change very much when you go from one point to the next, such a method works fine. You end up with a smooth looking curve, although it is really made out of tiny straight lines. However, if you're plotting a function which changes rapidly, like sin 5x does here, sampling at only 100 data points makes you miss many of the important features. In particular, it makes you miss the fact that this is really a smooth curve. How do I know that the sampling rate is 100? Well, just like set allows you to set various options, the show command actually allows you to see the values of these options. So if I type in show samples, it is going to tell me that the sampling rate is 100. The second 100 is not really of use to us right now. It is relevant for 3D graphs. On the x-axis, what you do sample are 100 points. Now this is not really enough for us. As long as we are plotting sin x, it was fine. But when I am plotting sin 5x, which changes more rapidly, a sample of 100 points simply will not cut it. So what do? We, of course, use the set command to change the value of samples from its default value of 100 to say 1000. Again, doing this has made no difference to the graph that is on your screen because it is only going to take effect for future graphs. So let's plot sine 5x again, and now you see that the graph you get now is more like it. A nice smooth graph which goes all the way from -1 to +1 on every one of the swings. How big can you make samples? I don't really know for sure, but I guess you can make it as big as you want. Of course, it has to be a reasonable value. If you make it too big, it's going to take gnuplot a long time to plot your graph. To sum up, the value of 100 for samples is usually fine. If it is not fine, as you can make out by looking at the graph, you would like to increase the sample somewhat. But 1000, 10,000, don't go much beyond that. If you did, your graph may come out smoother and looking nicer, but it will come out only after a long agonizing wait. So well, all I have to say is be smart about it. Don't go overboard and increase samples to a huge value. Well, so far all we have done is plot only one curve in a graph. Can I draw more than one? Of course I can. Let's plot sin x and cosine x together on the same graph. This is how you do it. You type plot sin x, cosine x. You have to separate the various curves that you are plotting on the same graph by commas. And there you have it. The blue line is for the first function that you asked gnuplot to plot, which is sin x. The green curve is cos x, which as you can see is leading the sin x graph by 90 degrees. Note that the peak of the green curve, the cos x graph, comes before the peak of the sin x curve. So it is actually leading the sin x curve. Can I plot more functions? Again, I can, but within reason. Plot too many curves on the same graph and it might get too cluttered to be of any use. Suppose I want to plot cos x whole square as well. Then I simply say cos x double star. By the way, double star stands for power and double star 2 of course is power 2. Just remember, although we write cos square x in maths, we are not really squaring cosine. We are evaluating cosine x and then squaring the result. So gnuplot, and in fact almost every programming language demands this, insists that you write it the way it is supposed to be. Cos x and square of that, not cos double star 2x. And now you have three curves. The first curve, the sine curve, is the blue one. The green curve is cosine x. And the cyan curve, which frankly I can't really differentiate very well from blue or light green or green, is the third curve. Which you can see is also labeled here. Cos x square is being plotted with a cyan line. So in this case, where you have three curves on the same graph, the legend actually comes out to be quite handy. Well, there are other features that you may want in a graph. For example, you may want to label the x-axis, label the y-axis, give the graph a title, and so on. As you can guess, you can do all that by using the set command. Just say set x label, for example. But now you have to give the value of the label within quotes. That is because the value is a string and strings are entered in quotes. So I have set the set label to x, rather unimaginative. I will then set the y label equally unimaginatively to y. Then I can set the title of the graph to my graph. And then plot the curves again. Okay, let's make a slight change here. Let's do this. I am actually setting titles to the individual curves also. And notice that the titles are in quotes because they are strings. This may end up becoming a bit confusing. Unfortunately, gnuplot uses the same word title for both the graph as a whole, in which case that's the title of the graph as a whole, and for the curves individually. But in the case of the curves, all that changes is really what you're writing on the legend. So, for some reason I forgot to actually hit the enter after entering the plot title, so I have to do it again. Oops, it's not plot title. That's completely wrong. It's set title, as I have said before. By the way, you have just met your first gnuplot error. It's just saying undefined variable title. So what I'm going to do is set the title value to my graph, not plot. Of course, all this, well, not all this, but setting the title to my graph has had no effect whatsoever on the graph that's on your screen, because this option will take effect only in the future. But going back to my plotting command, this is the effect of all that. The X label has changed to X, whatever I have specified. The Y label has changed to Y. The legends now bear the graph titles. So the graph titles SC and C2 rather than sin x, cos x or cos square x. And there is an overall heading, my graph, for the graph. Now that I have taken so much pains to plot a rather complicated looking graph, can I save this? The answer is, of course I can. There is a standard protocol for exporting graphs in gnuplot, that is saving them in various formats. But unless you need a lot of control on what you are saving, this protocol is a bit too cumbersome to be used on a regular basis. On my system, it's just easy enough to click on this arrow here, and then there are various options. You can copy this to the clipboard and then paste it onto your favorite graphics program or Word document or whatever. You can print the graph as is if you are connected to a printer, export to PDF or scalable vector graphics, or you can simply choose, and this is what I'm going to do, export to image. And if I click export to image, it's going to take some time and perhaps a warning message from gnuplot, which you can simply ignore. And now you have a choice of giving a name to your file and saving it. For the time being, I'm just going to cancel this. But if I had saved it, it will remain stored as a picture on my dictionary, whichever directory I want to save it to. Okay, so this is where our first installment on gnuplot ends. We will come back with more details on curve plotting using gnuplot. Next up, how to plot data which are already in a file. Bye for now and happy gnuplotting.